Hey folks, welcome back. In this video we're going to go over question 1 from the 2015 SQA National 5 Physics exam paper. So let's get started. Question 1 says a student sets up the following circuit using a battery, 2 lamps, a switch and a resistor. So there's a picture of the setup with 4 cells creating the battery. You've got 2 lamps labelled L and M, you've then got a switch and a resistor connected in parallel with lamp M. Part A says draw a circuit diagram for this circuit using the correct symbols for the components, and there's 3 marks available here. Well, the circuit diagram could look something like this, where firstly, to represent the battery, all I've done is drawn 2 cells joined together with a dashed line in the middle, and this is what you can do to represent a battery that is more than 2 cells. So I've saved myself a bit of work having to draw 4 cells by just drawing 2 with a dashed line between them. We've then got our 2 lamps or bulbs in series here with the open switch on the right hand side, and then we've got a resistor in parallel with the lamp in the middle. Now notice that we've used straight lines for the wires, so make sure you're using a ruler when you're drawing this by hand. Now remember there were 3 marks available for this, so where do you get the 3 marks? Well, first of all you get 2 marks for the symbols. If they're all correct you get the 2 marks, but if not all of the symbols are correct you can still get 1 mark for the symbols if at least 2 different symbols are correct. And the last mark comes from drawing the wires connecting the circuit, so you get 1 mark for the correct representation of the external circuit wiring with no gaps. So the only gap you should have in the circuit is at the switch because it was open in the diagram. Part B says each lamp is rated at 2.5 volts and 0.50 amps. Calculate the resistance of one of the lamps when it is operating at the correct voltage, and there's 3 marks available here. Well, writing down what we know from the question, we're trying to calculate the resistance R. We know the voltage V is 2.5 volts and the current I is 0.50 amps. So writing down our equation relating resistance, voltage and current, we have V equals IR. Substituting in the numbers gives 2.5 equals 0.50 times R, and to get R on its own we want to divide both sides by 0.50. So doing that we get R is equal to 2.5 divided by 0.50, which if you put into your calculator should give you an answer of R equals 5 ohms. Lastly, part C says when the switch is closed, will lamp L be brighter, dimmer or the same brightness as lamp M? You must justify your answer, and there's 3 marks available here. Well, remember this statement, you must justify your answer, means that if you don't justify your answer, you're going to score 0 marks, even if your conclusion is correct. So make sure you justify your answer here. Now looking back at our picture of the circuit at the start of question 1, we want to know what happens to the brightness of lamp L when the switch is closed, and we want to compare its brightness to that of lamp M, which is in parallel with the resistor. And we can say that lamp L will be brighter since lamp M is in parallel with the resistor, and therefore there's a greater current in lamp L than in lamp M. So my conclusion for 1 mark is that lamp L will be brighter, and then I've got 2 reasons for the justification to give me 2 extra marks. So we're saying first of all that lamp M is in parallel with the resistor, and then we're saying there's a greater current in lamp L than in lamp M. And notice how parallel is underlined, which means you need to say parallel in order to get that 2nd mark. Or another way you can answer this is by saying that lamp L will be brighter since lamp M is in parallel with the resistor, and therefore there's a greater voltage across lamp L than across lamp M. So this time our first 2 marks are the same. We've got lamp L being brighter and lamp M being in parallel with the resistor, but now instead of talking about current in lamp L, we're talking about the voltage across lamp L. So you can answer it either way here. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video one of these, subscribe to the channel, and I'll see you in the next one. Take care.